Welcome to our video presentation for the Onion workshop. My name is Daniel Schlör from the University of Würzburg, Germany, and I'm presenting our work Improving Sentiment Analysis with Biofeedback Data. What is the motivation behind our study? To build a sentiment classifier, you need a labeled dataset for the kind of text you're using. For English text, there are many datasets available, for example, English tweets, or Amazon and movie reviews, which were annotated with sentiment. But for non-English languages, the datasets are quite rare, and to create a sufficiently large one is very time-consuming, especially if you think, for example, for a sentiment classifier which can be used for novels or books or book chapters. On the other hand, reading the text is relatively easy and can be done quite fast in comparison to annotation. And we know that reading also induces physiological reactions. Think, for example, for heart palpitation for a thrilling book. And these physiological reactions can be measured as biofeedback. So the question is, can we use biofeedback data that is captured while reading to support a sentiment classifier in its decision? And we know measuring heart rate, for example, is very easy nowadays using fitness trackers or smartwatches, and even EEG data can be captured using fairly inexpensive equipment. In this work, we are evaluating two sentiment-related tasks. Sentiment detection, which is to answer the question, does this sentence convey any kind of emotion? This task had the purpose of speeding up the labeling process by asking the annotators only for labels of emotional sentences. On the other hand, the second task, sentiment classification, to answer the question, does this sentence convey any positive, neutral, or negative emotion? This aims at automatically pre-labeling the dataset in a way that an annotator would only have to check if the assigned label is assigned correctly. Here you can see a sample application for the sentiment detection task. A biofeedback enhanced annotation process could use biofeedback data from multiple persons, then find emotional passages using our classifier, and finally present these passages to an annotator to avoid the tedious work of annotating neutral sentences without any emotional label. We collected a dataset consisting of two main parts, the text data and the biofeedback data. The text data consists of 4 German medium-length texts. They were annotated with sentiment polarity. They have different topics and different text types, and they were chosen to trigger different emotional reactions of the reader. The biofeedback data was recorded in a study where the participants read the texts, and the biofeedback was collected using a smartwatch sensor and consumer-grade EEG sensor. The texts chosen for this dataset are written in German language and have a length between 502 and 633 words. The text we called Kangaroo is an excerpt from a book by Marc-Uwe Kling, which is called Die Känguru-Chroniken. It's a fictional story where a man and his friend, which is a kangaroo, come into trouble and experience absurd but funny situations at the security check. The difficulty with this text is that the situation is not that pleasant for the protagonists, but it's quite funny for the reader. The text Dogs is a neutrally written factual text taken from National Geographic's about early dogs as pets or companions. The text Genie is a report with many negatively connotated words. It's a story of a girl who is neglected and abused by the parents and who never learned to speak. And the girl became subject of many scientific studies just to be left alone afterwards. So it's a quite sad story. And finally, the story James is a chronological, relatively neutral description of a boy tortured and murdered by two other boys. The four texts were annotated sentence-wise with sentiment polarity, so positive, negative, neutral. They were annotated by 3 different annotators, and we obtained the final label by majority vote. Of course, we have 3 different labels, so there is possibility that each annotator chose a different label, which happened for the text kangaroo for 6 sentences. You can see the number of sentences which we could apply majority vote in brackets in the table. We could obtain majority vote for dogs for all sentences. 2 sentences were ambitious for Jeannie and 2 for James. These sentences were excluded for our study. And you can also see the distribution of negative, neutral, and positive sentences. The second part of the dataset was collected in a study of 15 participants. All participants were German native speakers who read the text using the smartphone app BioReader, and they were wearing a smartwatch, the Polar M600 smartwatch, which collected the heart rate with a frequency of 2 Hz. And the reading progress was captured along with the sensor data, page-wise. Finally, the sensor data was linearly interpolated for each sentence to obtain sentence-wise heart rate values. The second part of the dataset was collected in a separate study. We used the OpenPCI consumer-grade EEG sensor with a headband of 8 electrodes. We collected the data with a sampling rate of 250 Hz. This resulted in roughly 400,000 data points, which were sentence-wise aligned with the text. So how did we extract the features? The text features, on the one hand, were obtained using the text block classifier with simple negation detection. We mapped words to their sentiment scores between -1 to 1 based on the lexicon, and we calculated the sentence score as an average over the sentiment scores of the words. On the other hand, the biofeedback features consist of the EEG data and the heart rate data. The EEG data was prepared using a Fourier transformation. We applied a bandpass filter between 30 and 30 Hz, and we applied principal component analysis to reduce the number of features, and we found that 3 principal components worked best for our experiments. The heart rate was normalized for each reader and then averaged for each sentence, and we also obtained the change of heart rate as feature. In our study, we compare 2 classifiers. We use a linear support vector machine and a random forest. And the input for our classifiers is the concatenation of all features. So for our experiments, we use 5-fold cross-validation, which was repeated 10 times to remove random influences. We are evaluating both classifiers using different combinations of features, so text features, EEG features, and heart rate features. And we are evaluating both tasks, sentiment detection and sentiment classification. The baselines for our experience are the majority vote and stratified random sampling. On this slide you can find the results of our study. You can see that text is the strongest single feature set in both tasks, and you can also see that adding heart rate and EEG features help for detection but not for the classification task. This is in a way expected for the heart rate, where you can think of both positive and negative excitement leading to an increase of the heart rate. But this is somewhat unexpected for the EEG features, which should represent the emotional state more accurately. So we found that biofeedback data contains information which can improve text-based sentiment detection. We also found that the performance of a heart rate-based sentiment detector is comparable to text-only sentiment detector. And we showed that heart rate, EEG features, and text features together achieve the best results for sentiment detection. For future work, we plan to collect EEG data in a larger study using more participants and to extract other features. We also work on a better ground truth labeling process to avoid missing sentences where the majority baseline couldn't be applied. And as a third step, we have the BioReader smartphone app, which records the sensor data. And for this app, we also want to use the front camera to record facial expressions and include them in our classification framework. So to summarize, we found that biofeedback signals such as heart rate and EEG can be useful for sentiment analysis. We created a new dataset including sentiment annotations and biofeedback data for 4 German medium length texts. You can find the paper using this link, and the dataset is freely available for your own experiments. If you want to contact us, if you have questions or suggestions, you can find our email addresses on this slide. Thank you for your attention.